Let's take a look at the next part of the quadratics topic. So this bit now talks about the discriminant and the nature of the roots. Now we seen something about nature in the last topic back in Unit 3, but that was us talking about the nature of the turning point. This is actually talking about the nature of the roots. Okay, so let's consider these three situations here. I can use the quadratic formula to find the roots of each graph. So here's the formula that we already know. I have already subbed in the numbers here for A, B, and C. Let's just go ahead and fill this out and complete it. So the first one, for x squared minus 4x plus 3, let's complete this away. So minus 4 is going to be plus 4. So it'll be 4 plus or minus the square root of, and we have minus 4 squared minus 4 times 1 times 3, which is going to give you 16 minus 12, which is 4, all over 2. So x is going to be 4 plus the square root of 4, which is 2, over 2, or 4 minus 2, over 2. So that means the x has to be 4 plus 2 is 6, divided by 2 is 3. 4 minus 2 is 2, divided by 2 is 1. So the roots are going to be 3 and 1. Okay? So that would mean that this bit here is going to be 1, this bit here is going to be 3. Let's look at part 2 then. So we've changed the last number slightly and we've changed it from 3 to 4. So let's process it through. So we get x is equal to 4 plus or minus the square root of minus 4 squared is 16. Take away 16 all over 2. So 16 take away 16 is 0. So it's going to be 4 plus 0, which is 4. So it's 4 plus 0 over 2, or 4 minus 0 over 2. Let me just put that in there. So x is going to be 4 divided by 2, which is 2, and 4 divided by 2, which is 2 again. So here we have 1 point here. It's just going to be 2. For the last one, we've changed the last number to 5 this time. So we get x is equal to 4 plus or minus the square root of minus 4 squared is 16 minus 20 all over 2. So it's going to be 4 plus or minus the square root of negative 4 over 2. And that's where we have to stop with this one, because if you do the square root of minus 4, you'll see that your calculator has a wee meltdown because you can't find the square root of a negative number. And that's what this topic is now all about. Because for the quadratic formula, the most important part of it is the bit that's just underneath the square root. And that bit is called the discriminant. So the bit here underneath the square root is called the discriminant. And it's the most important part of the quadratic formula. Because as you can see, if you get a negative number underneath the square root, it doesn't work out. You can't do anything with it. And looking at that third diagram, well, that's a graph that doesn't go through the x-axis. It doesn't have any what we call real roots. Okay? So, let's have a look at some of the theory then. So in each equation, we only change the c value, yet all the roots are different. The nature of the roots is purely determined by the part of the formula inside the square root, and that's what we call the discriminant. So the discriminant is this bit here. It's called b squared minus 4ac. Okay? And here's some facts that I want you to remember. If the value of the discriminant is bigger than 0, so if that bit underneath the square root is bigger than 0, then we say that we have two unequal roots, either different or distinct roots. Okay? But we're now going to start talking about real numbers. Real numbers are numbers that exist in life. If you can see them, if you can touch them, then they're real. So if b squared minus 4ac is bigger than 0, then we say that we have two real and distinct roots. And that's what this first bullet point is here. If the discriminant is equal to 0, then we say the roots are still real because 0 is a real number, but they're also equal. And that's what we had in that second diagram when we had x is 2 and x is 2. So if the value of the discriminant is equal to 0, then we say that the roots are real and equal. In the third situation there, we had the situation where we had no x-intercept at all. So that means that we have no real roots. There are still roots, but they're not real. And believe it or not, we would actually call them imaginary roots. More about that when you get to advanced higher. Okay? So, looking at this, so in this situation, we can see that if we have a parabola that cuts in two different places or two distinct places, we can say that we have real and distinct roots. If we have a parabola that only cuts through the x-axis at one place, we can say that we have real and equal roots. And if it doesn't cut the x-axis at all, then we say that we have no real roots. Okay? So this next bit is going to get us to find the discriminant and state the nature of the roots. So to find the discriminant, all we do is use this expression b squared minus 4ac, because that is the part of the quadratic formula that we need. So if you think about the quadratic formula that's written as this, x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. This bit here is the discriminant, b squared minus 4ac. So learn that. The discriminant is b squared minus 4ac. So example 10, it says, find the discriminant and state the nature of the roots. So to do this, we find the values of a, b, and c. So in this situation, a is going to be 1, b is going to be minus 6, and c is going to be 9. So we have b squared minus 4ac. Put those values in. So we get minus 6 squared minus 4 times 1 times 9. So that will be 36 minus 36, which equals 0. So let's look at our list. What does that mean? If your discriminant is equal to 0, roots are real and equal. So just say that. So the discriminant is 0, so therefore roots are real and equal. Okay. The next bit we have here, a is equal to 2, b is equal to negative 4, c is equal to 5. So b squared minus 4ac, so that will be minus 4 squared minus 4 times 2 times 5, so that will be 16 minus 40, which will give me minus 34. Sorry, minus 24 I should say. Be good if I can count. Okay, so here our discriminant is less than 0. What does that mean? Well, it means that we have no real roots. So we can say, therefore, no real roots. And then the last one, we have to rearrange it a little bit before we do that, because we always must make sure that the right hand side is equal to 0. So that would give us x squared minus 7x minus 4 is equal to 0. Pick out your values of a, b, and c. So a is 1, b is minus 7, c is minus 4. So into b squared minus 4ac. So that'll be minus 7 squared minus 4 times 1 times minus 4. So that will give me 49 plus 16. So 49 plus 16 is going to give me 65. So we'll go back to the chart that we should be remembering here. It's bigger than 0, so roots are real and unequal. So therefore, roots are real and unequal. Okay.